Assalamualaikum and good day everyone. So as for today, we are going to continue with the design of connections and joints. Right, so basically as for today we are going to look into the types of connections that we are using in a skeletal structure. So in a multi-story frame, right, the fundamental is the connection between a vertical and horizontal components. Alright, so these are the most important thing that we have to consider in a multi-story frame design. So it can be either a vertical member that is continuous in design and construction terms, and horizontal frames are connected to it. Right, so it can be when we talk about vertical member, means that we are referring to the column. And as for the horizontal frames, so this is for the beams and also the slabs. And the second one, is when the vertical member is discontinuous. In construction terms, it's not that the column is discontinuous, which means that it cannot transfer loads downwards. However, in the construction process, the column is not considered as continuous. And horizontal components are continuous, or separated across the junction. Right, so let's see what does it mean by these two types of connections. So this is the first one, whereas we can see that the column is considered as continuous, or the vertical member is continuous. And we can see that we have the slab, and also the beam, that is half joint. Right, so and we can also see that in between these two columns, we have this compression loaded mortar joints, which is this joint. And as for the connection to the horizontal component, we have this half joint. Alright, so for this type of connection, it will give excellent performance, as the loadings, for the vertical loadings will be transferred directly here, and the joints are easily accessible to workers. Alright, so the joints, this compression joint as well as for the tension joint. The compression joint, that is for the horizontal member. Right, so and large forces are readily transferred from one column to another. Right, so this is for the first type. Then this is for the second type. Whereas we are considering that the horizontal member is continuous. However, as for the vertical member, which is the column, it is discontinuous. Right, so we can see here, that the compression mortar, or the compression joint here, is located on top of the beam. Right, so as for this one, when we have a beam passing over a column, it could give a better moment distribution over the beams. However, we have poorer performance at the column connection. Because instead of the column being attached to the column itself, it is attached to the horizontal component. Right, so as for this column, right, so the column has two mortar joints. Therefore negative moments from the beams, we are going to have negative moments from the beams, that will also affect the column. Whereas we are going to have the top part, that will elongate. Right, so we know that when we have a continuous beam, therefore at supports we are going to have negative bending moments. Right, and also it will also experience difficulty reaching the underside joint, which results in bad quality and poor stress transfer. Right, so we are going to have joints, like this, right, which will be quite difficult, to maintain. Right, so therefore it could result in poorer quality of the connection. Right, so then next we move on to the connection, to continuous column using hidden steel insert. Right, so steel inserts, steel inserts joints is the most common form of beam column connection. right? Okay, so this is when we wanted to connect these two. Okay, and this is another type. Okay, instead of having the usual cobalt, right, as what we have discussed previously. Right, so the mechanism, okay, is based on static strength, stiffness, load transfer into the connecting components, okay, temporary stability, and the structural integrity. Okay, right, so this is the basis, okay, of a beam column joint design, okay, that is using the steel inset. Right, so the steel inset, okay, that we are talking about, okay, is this one. Okay, whereas we are going to have this steel that is embedded into the column, okay, and this will act as the support, right, to the beam that will be assembled into the structure. Right, so we have this. Okay, so this is the column, okay, and this is the steel insert, right, and we are going to have the physical gap, okay, which will give us the structural discontinuity, right. So as what we have discussed previously, when we have a pin jointed component, right, okay, that therefore we are going to have this gap, right, okay, which we do not have any tension joint, okay, attached to it, right. Okay, so we are going to have this bearing pad, okay, which is connecting to the steel insert, right. So basically this is not only for steel insert, right, so it can also be a uh, cobalt, okay, and so on, okay, and others, right. So as for this one, this is actually representing the support, right. So this is our beam, right, and you can see here, okay, in the basis of the analysis, right, so we can see that we have three parts, okay. So whereas as for the part A, right, which is this part, okay, it is to transfer the beam's shear force to the connection, right. So this is the function of this part. Okay, then as for that is for part A. Then as for part B, okay, it is to ensure adequate shear capacity, right. As you can see here that the links is much closer, right. Okay, then this part, okay, which is also part B, is to be taking the shear capacity, okay, and as for this C, okay, is to transfer the compressive loads, okay, into the RC column, okay. Right, so this is one example, okay, of having a beam to column insert, right. Okay, so we have pockets in columns, okay, with threaded couplers, okay, used at external columns, right. So we are going to have these reinforcements, okay, and this is our beam, right, and we can see that we have a solid steel or rectangular hollow belay, right, okay, which is the place, okay, whereas we are going to have our um, supporting element, okay, to the beam, right. So this is our beam, right, so therefore we need to have the encourage to shoe as well, okay, and uh, okay, so this is for solid or hollow belay, okay, with a top steel reinforcing bar, right, okay, which is this one. So we have the reinforcing bar. Okay, so the next one, okay, is a solid or hollow sections, okay, with threaded dowel or top angle fixing. Right, so as for this one, okay, we have this dowel bar, okay, and we have top fixing, okay, top fixing cleat, okay, or similar, right. So we have this tension joint, right, okay, then we have our column, right. So this is the leveling shims, okay, or the bearing, okay, bearing pad, and we have the bolt or threaded dowel, right. So um, and we are going to grout or concrete this part, right. Okay, so we can see here, okay, that this is the solid or hollow steel section, okay, that is cast into the column, right. So this will be the column insert, okay. Then the next one is solid belay with welded plate in beam, right? So as for the welded plate in beam, right? So we also have another thin plate, okay, that is connected to beam, right? So this is the thin plate, okay, and this is the solid belay, right? Okay, so this is embedded inside the column, right, and we are going to attach this, okay, by full penetration fillet weld, right? So we are going to use the welding method, right? So here, okay, we are going to have the projecting bars, okay, for temporary flexibility, okay, and this is where we are going to have the weld, okay, between the connection, right? So this is the part that is connected to the column, and this is the part that is connected to the beam. Okay, right, then we also have open box and notch plate in beam, right? So as for this one, okay, we are going to have the notch, okay, which is provided, okay, in the beam insert, right? Okay, whereas we have this part, okay, and we also have the sliding plate, okay, that is embedded inside our concrete, okay, and we have the steel box anchored into the precast column, okay, whereas this is where, okay, we are going to attach this notch from the beam, right? So this will be attached to this column, right? So this notch, okay, will be the lock, okay, between the beam and also the column. Okay, this is another one, okay, whereas we have bolted end plate, right? So bolted end plate, so we are going to have this plate, okay, and we are going to bolt, okay, these two elements together, right? So we can see that we have bolted connection, okay, between the beam and the cleat, right? So we are going to have to do a calculation, okay, in view of the number of bolts that we are going to use, okay, at this section, right? And we also have this section of fully anchored sockets, okay, that is cast into the column, okay. Right, so this is one example, okay, of the column insert, right, that we have discussed just now, okay, whereas we have the plate, okay, with the notch, right? So we can see here that this is the plate that is coming out from the beam, right, and we have this notch, okay, and this part, okay, will be inserted into this box, right? So we can see here this is the box, okay, that we have discussed earlier, okay, which is this one, right? We have open box and notch plate in beam, right? So this the figure that is shown there, okay, is this one, okay, which is the sliding plate, okay, that is coming from the beam, okay, and also we have this box, okay, steel box that is anchored into the precast column, right? So this is the box, okay, in the column, and this is the plate in the beam, okay. And this is also another type, okay, whereas we have a multi-sided wide section insert, right? So as for this one, it is using the bolted connection, right? Okay, so in 3D we can see that it can be connected, okay, inserted into this column, okay, in both directions, okay, on this side and also on this side. Okay, right, so general design of column insert, right? So these are the things that we have to consider, right? Okay, which are the compressive loadings, okay, or compressive stresses. Okay, so we need to have the cover to links, okay, and we have the column reinforcement, right? Okay, and also we need to consider the value of shear that is acting, okay, at the support, right? So we know that the maximum shear happens near the support, right? So that would be the most critical value that we have to consider. Okay, right, so hollow steel section in a deep column, right? Okay, when we have a hollow steel section, okay, that is embedded, so there is a possibility of cracking, okay, if the actual load is small. Okay, and the flexural corrects at top of insert, okay, as insert deflects downwards, right? So these are possibility of failures, okay, when we are using the hollow steel section in a deep column. Okay, right, so this is for the design of confinement links, okay, around the column connector, right? Okay, so we can see here, okay, when we are dealing with the shear happening near the support, right? Okay, so therefore we need to have these links, right? So these are known as the confinement links, okay, which is around the column connector, right? So we are going to have this confined concrete, okay, inside the links, right? Okay, so this is for the column connector or the column insert, right? Okay, so this figure, okay, is in the longitudinal view, okay, and this is in the plan view, right? Whereas you can see that we need to have this links, okay, to cater for the forces. Okay, right, so this is the arrangement of reinforcement, okay, whereas we have cast in roll hitch section, right? So this is the arrangement of the reinforcement as well as the steel plate, okay, inside a beam, okay, inside a column, okay, before concrete is cast, right? So we can see that it has to be confined, okay, with the links, right? So we have the links on top and also we have the links at the bottom, right? Okay, and we have this H section that is located in the middle. Right, so what is this? So this is additional tie back reinforcement, okay, which is welded to the insert, right? So this is also for the additional reinforcement that is inside the column, okay, in order to fully secure our steel insert. Alright, okay, so we have the inserts, okay, which is made out of steel, right? So it will be bars, okay, that is welded to the remote end of insert. So this is one example, okay, whereas we have only one bar provided, okay. Then as for this one, okay, we have the bars, okay, that is welded on two sides, right? So we have this one, okay, and also this one, right? So these bars are welded to sides of inserts at front and rear, right? So as for this one, okay, we only provide at the back of the insert, okay. However, as for this one, okay, it is covering both, okay, in front and also back. Right, so this is double-sided belay, right? Okay, whereas we have both sides, okay, that is to take the loadings from the beam, right? So this is similar to what we have discussed previously. Okay, right, so as for this one, okay, so this is a 3 or 4-way beam to column connector, right? So refer to number of sides, okay, which a column is loaded, right? Okay, so as for this one, okay, we have to consider, okay, which sides, okay, that we are going to have the beam, okay, right? So we are going to have this side, okay, and also we have this side. Okay, then we also have a narrow plate column insert, right? So this is where we have this plate, okay, which is a narrow plate, right? And we may require additional top bearing plate, right? So when this plate is very thin, okay, or narrow, right? So therefore we need to have a proper uh, support, okay, that is inside the column. Okay, so this is cast in socket, right? Okay, so we have the pin welded to head, right? Okay, and we have the threaded barrel, okay, right? So this is another type of column insert. Okay, right, then we also have bolts in cast in sleeves, right? Okay, so when we already have this cast in sleeves, okay, that is in our column, right? Okay, so we can just fix our beam, okay, to it. Okay, then we can connect using the bolts, right? So we can see here, okay, that we have the bolts for the sleeves, right? Okay, so this is also another one, right? So what we are seeing just now are the inserts, right? So this is when we have the columns, okay, that is using the concrete ledges, right, or also known as the corbels, right? So as we have discussed earlier, okay, in this topic precast, right? So mostly we are seeing, okay, in the examples, okay, that we are using corbels, right? So this is one example of a shallow corbel, right? Okay, whereas we can see that this corbel has to be cast together with our column, right? So this is the example of reinforcements, okay, in the corbel, right? So we are going to have the reinforcement that is particularly for the column, okay, and we are going to have the reinforcement that is particularly for the corbel as well, right? So this corbel, okay, has to be designed, right, in order to cater for the shear forces, okay, that is acting on top of that particular area, right? Okay, so we can see here that at the corbel itself, here, okay, we are going to have the links as well, okay. Right, so as for this corbel, right, so we can actually design this corbel for only one side, okay, and also we can design the corbels for both sides, okay. Right, so this is for deep corbel, right? So this is the example of the forces that is acting in the corbel, okay, as well as the arrangement of reinforcements in the corbel. Right, okay, then we also have a haunch column, okay, whereas we are having this part, okay, which is the L shape, okay, that is to take the position, okay, of the beam. So it provides a sufficient bearing surface, okay, at level of beam soffit. Okay, so it is not desired in multi-frame as column dimension increase a floor level. Okay, so this is beneficial for cantilever action, okay, or when other type of connection cannot accommodate. Right. Okay, so this is also another type. Okay, whereas we are going to have multiple um, width, okay, of our column, right? So if we are to have this, okay, therefore you can see that we have a larger width here, okay, then the column width is decreased, okay, to this size, right? Okay, then only we can provide this haunch, okay. Right, okay, so these are the details, okay, whereas we are going to require the reinforcements, okay, at this parts, okay, so that we can place the beam, okay, ends of the beams in the column. Okay, right, so this is for the example, okay, of connection at top of columns. Okay, so we have a simply supported beam, okay, that is placed on the column, okay, and also we have a continuous beam, okay, so continuous beam, okay, with this column, okay, that is connected to a vertical member. Okay, right, so as for this one, okay, we are moving on to the beam to beam connections, right? So the connection between secondary and also primary beam. Okay, so we have special attention, okay, due to combinations of bending moment, shear forces, okay, torsion, and also bearing stresses. Right, so these joints, okay, tends to be avoided, okay, probably because their simplest forms are not normally appropriate to the client's requirements. Right, so usually in a precast concrete structure, okay, it is seldomly used, right, for this primary and also secondary beams, right. So in addition, pretension floors have excellent span potential, so that the concept of main beams, secondary beams and slab can often be dispensed, okay, with and replaced with beam and slab. Right, so basically when we talk about precast concrete structure, usually we are going to have only primary beam. Alright, so with very less secondary beam. Alright, so usually we are trying to avoid, okay, to have the beam to beam connection, okay, but instead we are going to have the beam to slab connections. Okay, right, so these are the examples. Okay, if we are to have the beam to beam connection. Okay, so we have pocket bearing type, okay, which looks almost like the beam column connection that we have discussed previously. Okay, and also we have the direct bearing type. Right, then this is the side shear box type, right? Okay, and we also have with in situ infill. Okay, so this is for column splices, okay, whereas we have structural connection made between column to column or other precast elements. Okay, right, so normally, okay, precast designer prefer staggered arrangement, okay, with the choices of splice is more to side erection consideration rather than strength. Okay. Okay, so we can see here this is the connection, okay, between the columns, right? So we have this example, okay, whereas we have a couple joint, right? So whereas we are going to have a turnbuckle here, right? Okay, so we are going to have to provide, okay, the easy to concrete. Right, okay, then we also have another one, okay, whereas we have this welded plate, right, connecting these two columns together, right, so this is the place, right, the plate, right, then another one, okay, is this one, okay, whereas we have this grouted sleeves, right, so this grouted sleeves, okay, means that we are going to have the projecting bar, okay, that is from the below column, okay, then we also have the holes, okay, in the top columns, right, so therefore once we fix these two columns, okay, at the grouted sleeves, at the sleeves, right, therefore it can the holes can be grouted, okay, to secure the connection. Right, okay, then we also have this welded lap joint, right, so for this welded lap joint, right, we are going to have these bars, okay, that is welded together, okay, at the connections, right, so later after it has been welded, okay, then it will be grouted, right, so this is almost similar to the grouted sleeves. Right, then we also have grouted splice sleeve, right, so as for this one, okay, we are going to have the steel splice sleeve here, right. Okay, right, then this is another one, okay, whereas we have this column splice shoe, okay, right, so as for this part, okay, usually we are going to have this bolted connection, right, so we can see that in the column, okay, we already have this part, okay, whereas we have the plate connected to the column, right, okay, so as for these bolts, okay, it will be connected to the next column, right, okay, so this is for the steel shoe splice, okay, and also we have column to hollow core slab, right, okay, so this is the hollow core slab, right, and we have the column that is connected to it, right, so therefore it is hold, okay, using bolts, right, so we have these bolts, okay, and we have the plate that is already being provided, okay, in the column, right, so this is when we have the connection, okay, between the column to a hollow core slab. Right, so next, okay, we move on to the column based connection, right, so previously is the column to column connection, right? And this is for the column to base connection. So basically there are three main types, okay, of column connections to foundations. Okay, so the first one we have grouted pocket, then we have base plate, and also we have the grouted sleeve, right? So this is one example of a column in pocket foundation, right? So we are going to have this pocket, right, which is the place where we are going to uh, put in the precast column, right? Okay, so we are going to have the leveling shims, okay, to adjust on the level. Okay, then we have the in situ concrete foundation, right? So this is the foundation, right? And the submerged part of column surface, okay, is roughened, okay, and in situ concrete, okay, or grout, okay, is placed, okay, at this part, right? Okay, so this is the example, okay, of having a column in a pocket foundation, right? So next one, okay, this is when we have the base plate, right? Okay, so we have the precast column, okay, and also we have the leveling shim, okay, and we are going to have this base plate, okay. So this base plate, okay, and we are going to bolt, okay, the column, okay, and also the foundation, right? So we have the holding down bolt, okay, that is already being prepared, okay, in the foundation, okay, then it will be connected to the base plate, okay, that is from the precast column, right? Okay, so this is another type of column based connection, okay, whereas it is using the bolting connection. Right, so here, okay, we have the example of a flush base plate, right? Okay, so this is where, okay, we have this base, okay, that is already being placed, okay, readily in our precast concrete column, okay, and this is the fully weld steel base plate, okay. Right, so and this is the example of a grouted sleeve, right? So what you can see here is the foundation, okay, with the holes, okay, that has been prepared in the foundation, okay, which is prepared for the column, okay, to be placed, right? So as you can see here, these are the holes in the foundations, okay, and we are going to have, okay, this reinforcement, okay, placed in the column, right? Okay, so that it can be fixed in, okay, to the foundation, right? Okay, so the location of this reinforcements, okay, as well as the sleeves, okay, has to be accurate, okay, in order to match between the precast elements, right? Okay, so this will be the last one, okay, for the base connection, right? So as you can see just now, okay, we have three types, okay, for the connection from the column to the base, okay, whereas we have the grouted sleeve, right? Okay, then we also have the base plate, and also we have the column in pocket foundation, okay, right? So with that, thank you very much. Assalamualaikum.